Lesson 3.3, Prove lines parallel. Before I move on with the lesson, I would like you to keep in mind that a proof can also be written in paragraph form. But in this lesson, let's just first focus on proving using a T-chart. Now, let's look at the corresponding angles converse, which is just the opposite of the corresponding angles postulate. So it states that if two lines are cut by a transversal, so the corresponding angles are congruent, so angle 2 is congruent to angle 6 here in the picture to the right, then the lines are parallel, meaning J is parallel to K. So I'm going to write the word congruent here. Okay, so this is, remember, the opposite of the corresponding angles postulate in lesson 3.2. Okay, example 1. Find the value of x that makes m parallel to n and a parallel to b. So I need to set 2x plus 3 equal to 71. Now I can solve. And then the other one, okay. Let's look at 3 more converses. The alternate interior angles converse, which is the opposite of the alternate interior angles theorem, which, remember, in 3.2, it's when two parallel lines that are cut by transversal, then the alternate interior angles are congruent. But when we reverse that statement, then we would say if two lines are cut by a transversal, so the alternate interior angles are congruent, angle 4 congruent to angle 5 here, then the lines are said to be parallel. And the same goes for the next one. The alternate exterior angles converse. The opposite of it was the alternate exterior angle theorem, where it states that when two parallel lines are cut by a transversal, then the alternate exterior angles are congruent. But here, for the converse, you have to first state that if the two lines are cut by a transversal, so the alternate exterior angles are congruent, then the lines are said to be parallel. And the same logic holds for the consecutive interior angles converse. If the two lines are cut by a transversal, so the consecutive interior angles are supplementary, then the lines are parallel. Please pause the video and take a moment to compare your notes from this lesson to the last lesson and compare the theorems. Look at how the statements are reversed. Example 2. How can you tell whether the sides of the flag of Nepal are parallel? So we want to look at the little arcs here. Since they're the same, so it's representing that these two alternate interior angles are congruent. So you can just simply say, because the alternate interior angles are congruent, so you know that the sides of the flag are parallel. Example 3. In the figure to the right here, A is parallel to B. So a tip would be to mark it in your picture. And angle 1 is congruent to angle 3. And I want to prove that X and Y are parallel. So if A is parallel to B, then I know that angle 1 and angle 2 will be congruent by the corresponding angles postulate. And I also know that angle 1 is congruent to angle 3 because it's given. And I could do the transitive property to prove that angle 2 is congruent to angle 3 to prove that x and y are parallel. So now this is my logic in proving this statement here. So I'm going to write A is parallel to B given angle 1 is congruent to angle 2. Remember I told you earlier, angle 1 is congruent to angle 2 because A and B are parallel. So corresponding angles postulate. Now I can use angle 1 is congruent to angle 3 given, and I can say angle 2 is congruent to angle 3 by the transitive property of congruence. And then, because angle 2 and angle 3 are congruent, we can say x and y are parallel by the alternate exterior angles converse. Now I would like you to pause the video and take a moment to try example 4 on your own. And then continue to play the video to watch how I prove this statement and then compare. Example 4. In the figure, x is parallel to y. I'm going to mark that in the picture. And angle 1 is congruent to angle 3. Prove that A and B, line A and line B, are parallel. To prove line A and line B parallel, I need to perhaps state that angle 1 and angle 2 are congruent with my given information. So I'm going to begin with x is parallel to y. Given. When x is parallel to y, then I know that angle 2 will be congruent to angle 3. I'm going to write that down here by the alternate exterior angles theorem. And now I also know that angle 1 is congruent to angle 3 because it's given. And now by the transitive property, I can state that angle 2 is congruent to angle 1, which was what I wanted in the beginning. Transitive property of congruence. And now that I proved that angle 2 is congruent to angle 1, I can state that A is parallel to B by the corresponding angles converse, which is the opposite of the corresponding angles postulate. And lastly, we have the transitive property of parallel lines, which states that if two lines are parallel to the same line, then they are parallel to each other. So if P is parallel to Q, Q is parallel to R, then we can say that P is parallel to R. So a quick example here, each utility pole, so these are utility poles, is parallel to the pole immediately to its right, so these are all parallel to each other. Explain why the leftmost pole is parallel to the rightmost pole. So I can use a simple sentence saying T1 is parallel to T2. So this is T1, T2, T3, T4. Then T2 is parallel to T3, then So T1 is parallel to T3, and the pattern will continue. Okay, in this video I've shown you some basic proofs. In class I will continue with more.